The first bond is this carbon-oxygen bond, which could be broken, and the other one is the oxygen-hydrogen bond. Okay, so we are going to look at two different reactions. First of all, we are going to look at the reactions that involve the breaking of, OH bond, and then we have the breaking of carbon-oxygen bond. The breaking of carbon-oxygen bond. Okay. So after this, first of all, we are going to look at the breaking of the reactions that involve the cleavage of OH bond. Okay. Please write A part of the reaction. There are two types of reaction that we are going to see in alcohol. Number A is reactions involving cleavage of OH bond. Reactions involving cleavage of OH bond. Now for this, you write number one reaction. Reaction with active metal. Okay. So please write alcohols are weak acids. Alcohols are weak acids, and hence they react with active metal. Hence they react with active metals such as sodium, magnesium, aluminium, etc. They react with active metals such as sodium, magnesium, aluminium, etc. to liberate, that means to give out, to liberate H2 gas and form metal alkoxide. Okay, so we have ROH plus metal. This will give you MOR plus H2 gas. Now, for example, if I take CH3OH plus sodium metal, then the valency of sodium is 1. So that is why it is going to make sodium, and you will have only one alkoxide, OCH3. This will be known as sodium methoxide. Sodium, this is alkoxide, and which is methoxide. And hydrogen gas will be liberated as. Okay, so maybe you have learned this reaction in even in 10th standard, not this particular reaction, but the reaction that acids react with metal. Acids react with metal to give what? To give salt and hydrogen gas. The same reaction is happening here. So alcohol is acting as an acid and it is giving you H2 gas. But let us suppose if I have CH3OH, the same methanol plus magnesium, then the valency of magnesium is 2. That is why it would need 2 sodium methoxide. So OCH3 whole twice plus H2. After this, CH3OH, if you have aluminium, then you will have aluminium whose valency is 3. So OCH3 whole thrice, and hydrogen will be liberated as before. Oh, if yeah. Write this down here. Then for before C, we have done just this much. Okay. So maybe you just write this part, and then for the above part, I will scroll up later on. Write this down. Let me know once you're done. Chacha, fine. Yes, take a screenshot. Yeah, and please start writing. Hope you took a screenshot. Okay, yeah. Okay. Is anyone still writing? Please let me know. Is anyone still writing? Is anyone still writing? Please let me know.
Yes, sir.
Achha, fine. Done, guys. Done writing?
Yes, sir.
Okay. Now please see. See, now since alcohols, they are acting as an acid, we'll talk about the acidic strength of alcohol. Please write next. Acidic strength of alcohol. So whenever we talk about the acidic strength, you have to first of all see what type of reaction is happening. We have RCH2, sorry, R CH2 bonded with OH. And then what is going to happen? Wait a second. Let me make this OH like this. Let me write everything down first, then you will start it. Okay. I will give you time to write. Don't write it now, just listen. So I have ROH, and this is acting as an acid, and it will be giving you RCH2. The hydrogen will be taken away, it will be liberated as H plus, and oxygen will get a negative charge, right? Oxygen will get a negative charge, plus you will have H plus. Now, this is acid. If you remember something from the 11th standard, this is conjugate base. What is conjugate base? Conjugate base is something that you get when you remove H plus from acid. You remove H plus from acid, whatever is remaining, that is conjugate base. Okay. Now, let us understand how acidic strength depends on different factors. First of all, what is happening here, we are breaking the OH bond. We are breaking the OH bond. And if this OH bond is more polar, that means there is more positive charge here and more negative charge here. Already broken, kind of, right? It will be easier to break if we have more positive on hydrogen and more negative on oxygen atom. That means it is depending on the polarity of OH bond. If the OH bond is more polar, that means more positive on hydrogen, more negative on oxygen. Why I'm saying more positive on hydrogen? Because it will be positive. As oxygen is more electronegative, it will pull the electrons from the hydrogen atom, making it delta negative, and this will be delta positive. Now, Greater the partial positive and partial negative charge, greater will be the polarity and easier will be to break this bond. Okay, one thing is that. Another thing, if you look at the conjugate base, it is having a negative charge. So obviously negative charge species, they will not be stable. That is why the acidic strength of anything, any species, it will depend on the conjugate base. If the conjugate base, if somehow we can make the conjugate base more stable, it will be happily moving, it will be happily transitioning toward the conjugate base. It will be happily giving out H plus ions because conjugate base is more stable. Okay, so factors affecting acidic strength are, please see, acidic strength will be directly proportional to the stability of conjugate base, and it will be directly proportional to the polarity of OH bond. To the polarity of OH bond. Now, after this, we are going to compare alcohol with certain things. First of all, we are looking at alcohol versus water. Alcohol versus water. Now, again, what we are going to do, please see, we have ROH. This is going to give you R positive, sorry, my bad, RO negative and H positive. Okay. If I have water, I will have HOH. This is water, giving you HO negative plus H positive. Now, if you look here, first of all, let us look at the conjugate base. So here the alkyl group is plus I group. It will be giving electron towards the oxygen atom, making it more and more negative. If the charge increases, it will become more negative, then the charge will increase. When the charge will increase, then what is going to happen? The stability will decrease. And obviously, R is what it is, a highly strong electron donating group. So it is donating electrons towards the oxygen atom, making it unstable. First thing is that. Another thing, if you look at the alcohol molecule, this R group is here also giving electrons toward the oxygen atom. So since R is already giving oxygen atom some electron, oxygen is getting electrons already from the R group. That is why oxygen is not taking much from the hydrogen atom. Okay. So what is happening in the alcohol case? The polarity of OH bond is not very high, and also the conjugate base is very unstable. So both of these factors, they lead up to the conclusion that alcohol are weaker base than water. Sorry, weaker acid than water. Alcohols are weaker acid than water. Why? First reason, please write. RO negative, that is the conjugate base. Alkoxide ion, we say that alkoxide ion. Alkoxide ion is unstable due to plus I group. Due to plus I group, what is the plus I group? R, the alkyl group. Another point, the alcohol is, wait a second, we should write it like this, the OH bond in alcohol is less polar due to the presence of plus I group, that is R. Therefore, alcohol is less polar, sorry, less acidic than water. All of you understood this? Yes or no? Please tell me. Let me know if you have any doubt here. Why alcohol is less acidic? Majid, Fia, Fadil. Oh, Majid, I think Majid is your first class now. Majid, am I audible? No. Fadil, Fia, Deborah, Aliza. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Okay. What about others? Fia, Aliza, Deborah.
Yes, sir.
Yes, now. Okay. So remember these 2 points. Okay. Stability of conjugate base should be high, and the polarity of OH should also be high. How much should I scroll up, Fia? Till here? Okay, write this down. Done, everyone? Okay. Right, next. Now we will look at 1 degree versus 2 degree versus 3 degree alcohol. Okay, now, as we have already seen in the previous case, that acidic strength it decreased due to the presence of plus I group, right? Why did alcohol had less acidic strength? Because it had a plus I group. That means if we have more plus I group, then what we will be having less acidic strength. That is why I can say, what is 1 degree alcohol? 1 degree alcohol will be something like this. You have R CH2 OH. This is 1 degree. What is 2 degree? 2 degree will be like this. R CH, one more alkyl group, and then OH. What is 3 degree? It will be R carbon OH R and R. Okay, so this will be 3 degree. So obviously we are having more plus I groups in the less plus I group in the 1 degree, then more in the 2 degree, and the most in the 3 degree. And this will be lowering the polarity of OH bond, and it will be also making the conjugate base very unstable, right? That is why the 1 degree, which is having the least number of plus I group, will be most acidic, followed by the 2 degree and followed by the 3 degree. So this is the order of acidic strength. One degree, 2 degree, 3 degree. All of you done? Yes or no? Please tell me. Let me know once you're done. Okay. No hurry. Let me know once you're done. Chali. The third one is alcohol versus phenol. Alcohol versus phenol. Now, we have already seen alcohol's case. R CH2 OH will give you R CH2 and O negative. And obviously this is unstable due to plus I group. Unstable due to plus I group. But if you look at phenol, phenol will give you phenoxide ion. And wait a second. Let me give the bonds like this. O negative. Okay. O negative. Now, this phenoxide ion here, it is resonance stabilized. Negative charge will come here. This bond will move here. Then the negative charge will come here, and then it will move here, move here. So the negative charge will be moving on, and that is why this is stable due to resonance. Okay. Now, first thing is that the conjugate base of alcohol, it is unstable due to plus I group, but phenoxide ion is stable due to resonance. So obviously phenol will be more acidic. Another reason you can see here, the carbon atom which is bonded to the oxygen here in phenol, this carbon atom, it is sp2 hybridized. And this carbon atom here, it is sp3 hybridized. Now the important thing about sp2 is sp2 is more electronegative. So rather than giving electrons towards the oxygen atom, it can pull electrons. If the sp2 carbon pulls electron from the oxygen atom, the oxygen will pull more electron from the hydrogen, making this bond more and more polar. So first of all, you will write that phenols are more acidic than alcohol because number one, phenoxide ion is more stable. Phenoxide ion is more stable due to resonance. Second point you will write OH bond in phenols are more polar due to the presence of sp2 carbon atoms in benzene ring. All of it done? Yes or no? Please tell me.
Yes, sir.
Now, after this, we will see two questions. Please write the question. A and B, we have two compounds, A and B, both contains OH group. A turns blue litmus to red. A turns blue litmus to red, but B doesn't. Identify A and B. Identify A and B. ठीक है? I will give you guys 2 minutes. Think about this question. Both of them are containing OH group, but one is turning blue litmus to red, but B is not turning. blue litmus to red. Yes, Pia, tell me. Yes, correct. And what about B? Okay. That is correct. See here, guys. So A turns blue litmus red. That means A is acidic in nature. A is acidic in nature. Please remember, when I say litmus now, then please don't understand that it is litmus paper. Okay. So litmus is actually a solution from which we make litmus paper. So litmus, it already has water molecule, and that is why if A is showing acidic nature in the presence of water, A is showing acidic nature in the presence of water, A is acidic in nature, therefore A is phenol and B is not acidic in aqueous solution. That means litmus is an aqueous solution. And as you know, our alcohol, it is less acidic than water. So in water, it will not act as an acid. Alcohol will not act as an acid in water. That is why it's not acidic in aqueous solution. Therefore, B is alcohol. Okay. Now, please remember a few things. If this question comes in board, then you have to write only this part. A is phenol, B is alcohol. Okay. Board does not want reason if they have not asked reason. See, in the question, they are saying just identify A and B. They are not asking you how you are identifying. Please tell me that also. No, you can keep your secrets with yourself. Okay. So you can just write A is phenol. If you are not able to get a particular frame, how to justify why is A is phenol, then don't worry about it. Okay. So write A is phenol, B is alcohol. If they ask you why, then you will just write A is more acidic than B. Therefore, A is phenol and B is alcohol. All of you got this? Yes or no? Please tell me. Understood, everyone? Deborah, Fadil, Fia, Aliza.
Yes, sir.
Fadil, what about you? Understood?
Yes, sir.
Right, next. Now we are going to look into acidic strength of substituted phenol. Acidic strength of substituted phenols. Number one, please write. See, when we are going to have substituted phenol, that means there will be some groups added to phenol. So the groups, if they are electron donating group, that means they are plus M. So they will be increasing the they will be increasing the negative charge. Therefore, the acidic strength will decrease. Acidic strength will decrease. And if I talk about electron withdrawing group, that is minus M. then the acidic strength will increase. So minus M increases the acidic strength and plus M decreases the acidic strength. Now please see here, if you have CS3, these are all plus M group, CS3, OR, OH, etc. All of these are what? Plus M groups. And for minus M, you will only see nitro group. Okay, so you can just write what is minus M, nitro group. So first thing is that you should be able to identify what is plus M and what is minus M. When I talk about OR, this can be OCS3, OC2H5 and other things also. So first thing is that you identify what is the substituent. Then you have to also identify what is the placement, where the substituent is added in phenol, ortho, meta or para. So phenol is like this. Benzene ring with a OH group, this will be phenol. This position is ortho. So if any group is attached on the ortho position, you are going to check is it plus M or minus M. Okay, is it plus M or minus M? You will check that. Okay, first check plus M or minus M, then check plus I or minus I, whether it is inductive effect plus I or minus I. Then you have the meta position. So if any group is added on the meta position, you only check plus I or minus I, because the resonance effect or the mesomeric effect is not shown if any group is on the meta position. So if it is added on the meta position, the mesomeric effect or the resonance effect is not shown. And at last, we have the para position. So in para, you will do the same thing as we have done in the ortho position. We are going to check the plus M or minus M, and then we are going to check the plus I or minus I. Please write this down. Let me know once you're done. So related to this, we have a few questions in NCERT. Let us see the first question here. Yeah. All of you wrote the question, yes or no? Please tell me.
Yes, sir.
No. So why explain why orthonitrophenol is more acidic than orthomethoxyphenol? Easy questions, right? Easy, very easy. You'll first of all see what is orthonitrophenol. Oh, sorry. My bad. This is orthomethoxy, na? I got para. I don't know why. Methoxy is OCH. Right. So what is this group? Tell me, plus I or minus I, guys. NO2 is plus I or minus I? Hanji. NO2 plus I or sorry, plus M or minus M? My bad. Plus M or minus M? NO2?
Minus M.
Minus M. And what about OCH3? Plus I or minus I? Sorry, plus M or minus M? My bad, guys. Plus M or minus M? OCH3 plus M or minus M. Fadil, you are not able to understand. Fadil?
Yes, sir.
Yeah, so tell me OCH3 will be plus M or minus M?
So plus M.
Plus M, yeah. You answer, okay? Please answer. This will
Okay,
be
sir.
plus M. Fine. Now, so what is minus M doing? It is taking the electron density from the phenoxide ion. Hai na? So you will write this stabilizes minus M. It doesn't. You will write it like this NO2. Also, it is in ortho position, so that is why we are looking at plus M or minus M. Otherwise, we would have looked at minus I or plus I if it was in the meta position. Okay. So please write here NO2 stabilizes phenoxide ion. NO2 stabilizes phenoxide ion due to minus M effect. And then you will write here OCH3 destabilizes phenoxide ion due to plus M effect. All of you done? Yes or no? Please tell me.
Done, sir.
Now there is one more question. So, right, this arrange the following compounds in increasing order of their acidic strength. Okay, so important thing here is that you should be able to write the structures. Okay, you should be able to write the structures. Now, just to make things easy for you guys, so here we have a comma. Here we have a comma. This is another compound. This is another compound, and this phenol is another compound. Okay, so phenol is one thing, and then here you have 1, 2, 3, 4, 5, and 6. So take 5. What 5 minutes is too much, but still take 4 minutes. Try to draw these structures. Once you're done, now you will send me the structures on my WhatsApp. Okay. Once you're done, you will send these structures on my WhatsApp. Is my voice breaking for everyone? Yes, Aliza, tell me.
No, sir.
Okay. Yeah, I think some problem is there from your side. So time is almost over. Send your answers, guys. How you have written these things. Show me the structure. Send whatever you have drawn, na, please send it to me on my WhatsApp. Whatever you have drawn, please send it to my WhatsApp. Okay. Okay, those two are fine. Alisa, you have sent me the structures, right? I have not saved your number.
Yes, sir.
Okay, I will save it just a second. Okay, so let us see. We have the first structure, that is propane 1-ol. So propane 1-ol will be, I think your structures are fine. So see, propane 1-ol, 1, 2, 3 carbon atoms and OH. 2,4,6 trinitrophenol. So we have phenol, OH, NO2, NO2, and NO2. And then you have 3 nitrophenol. So we have phenol, OH, and NO2 like this. 3,5 dinitrophenol, which will be OH, NO2, NO2. Then we have just phenol, and then 4-methyl phenol. OH and CS3. Now, first of all, we will see that, see, all of these are phenols. So obviously, all of these will be having greater acidic strength than the alcohol. They will be having greater acidic strength than the alcohol. Okay, so see, this is alcohol. We'll keep it separate. Okay. Now, after this, we will look at this particular molecule. This is having nitro, nitro, nitro. So it is having nitro. That means it is, and those nitros are on the ortho and para position. So it is having -M group. And how many -M group it is having? It is having 3 -M group. Can all of you see that? Yes or no? Please tell me. Correct, guys? हाँ जी बताएं. Aliza, Deborah, Fia.
Yes, sir.
Okay. Now let us look at this NO2. So this NO2 is in which position? Ortho, meta, or para? In the C structure. Tell me. In the C structure, NO2, it is in ortho group, ortho position, meta position, or para position?
Para.
हाँ जी. Para. Please see once again. The C structure. Deborah, Fia, tell me ortho, meta, or para? Aliza, ध्यान से देखिए. Is Deborah?
Meta, sir.
Meta position. Yeah, correct. So in meta position, do we see plus M or minus M? Do we see plus M minus M, or do we see plus I minus I? What do we see?
Sir, why meta?
What is meta position? Tell me.
The first one.
First one. nahi. See. We have OH. Okay. If the group is adjacent here, just after the OH, this will be ortho. If one carbon after the OH, then it is meta. If two carbon after the OH, then the group is known as in the para position. Okay.
Yes, sir.
So for example, if I have a benzene ring like this, OH, then what is this position?
Ortho.
Tell me. Ortho, है ना? So it, and what about this position?
Sir, para. Not para.
No, see, ortho means 0 carbon in between, meta means 1 carbon in between, para means 2 carbon in between. So look at OH and this group. How many carbon in between the OH and the group?
Okay, meta. Meta.
Got
meta.
it?
Yes, sir.
Okay. So I think this will be 3 minus M. We have to write this down. Now OH and NO2, this is minus I. Okay, nitrogen is more electronegative. So we are not looking at plus M or minus M. We are only looking at minus I. So this will be minus I only once. What about this one? This will be 2 times minus I because we have both these NO2 group on the meta position. This will be having nothing. And CH3, since it is a plus M group and it is also in the para position, it will be acting as a plus M. Now, when I talk about the acidic strength, A will be having the least acidic strength because it is alcohol and the rest of them are phenol. When I look at phenols, the minus I will be increasing the acidic strength, the plus M will be decreasing the acidic strength. Okay, and OH will be in the middle. When you have pure phenol, it will be in the middle. So that is why after alcohol, I can say that less than phenol is plus M, which is the F structure. So after alcohol, we will have the F. Then we will have the E structure that is not having either plus M or minus M. It is pure phenol. Now, when I look at the minus group, then I can surely say that, here I am having 3 minus M. So this will be most acidic. This is having only 1 minus I. And this is having 2 minus I. Now, when I compare the minus I, so I will say that after E, I will have C because it is having only 1 minus I group. After C, I will have the D because it is having 2 minus I group. But when I go to the B, it will be the most acidic because it is having 3 minus M group. So this will be the most acidic B structure. Okay, so you don't have to memorize anything. You just need to write things logically. So why did we write A? Because it was alcohol. Why F then? Because it was plus M. And why this? Because it is neutral, nothing. I mean, it is just pure phenol. There is no group here. And all of these are having minus I. And inside minus I, all of these are having electron withdrawing groups. And in the electron withdrawing groups, the minus I will be having the least effect. After that, the one which is having 2 minus I. After that, the one which is having 3 minus M. Okay. So please write this down. Let me know once you're done. Yes, Deborah, your structures are kind of fine. Is everyone done writing? Yes or no? Please tell me. Aliza, Deborah, Fadil, and Fia. Anyone still
One
writing?
second, sir. Yes, sir. One second.